Hello students, today I'm just going to again revise the topic that was already done in class so that it will be easy for you to follow the upcoming videos. So the chapter name is Electric Charges and Electric Field. As we all know, everything present in nature can be broadly classified into two main categories, namely radiation and matter. Matter is something which has definite mass and it is capable of exerting force. Already we have learned in detail about gravitational force. So what is the reason for gravitational force? Yes, the reason is mass of the body. Similarly, there is yet another very important force known as electrical force. And the reason for this electrical force is charge is present in the body. Right. So when I mean charges, you may question me that why then when I touch any, you already know that all bodies present in nature are having charges. So when we touch any body, we should experience electrical force, but that doesn't happen. Why? So when we say electrical force is due to the charges, we mean the net charge present in the body. So what is the meaning of this net charge? See, you can see that in the screen. Let us see this body. So it is having plus 5 charges and minus 5 charges. So what is the net charge? Net charge is nothing but you just have to sum up the charges. So if you see the net charge is plus 5 minus 5, so it is 0. See in the second case, it is having 5 positive charges and basically it is nothing but 5 protons and 6 electrons. In such case, if we see the net charges plus 5 minus 6, so it is minus 1. So what is the net charge of this body? It is minus 1, or we tell the body is negatively charged. Similarly, see the next case, the body is having 5 protons and 4 electrons. So net charge is equal to 5 minus 4, so we get 1. So this body is positively charged, right? So generally, all bodies present in nature are neutral, but we can either add or remove electrons from the body to get it charged, right? How do we, is there any method for charging? Yes, we have already learned 3 different methods of charging in detail. What are the 3 methods? Number 1, charging by friction. Just by rubbing both the bodies, we can charge the body. Number 2, charging by induction. That is bringing any uncharged body near, not touching, just bringing it near a charged body, we can charge it. Then charging by conduction. That is bringing them in physical contact, right? Next, what are the properties of these charges? So number 1, charges are additive. Suppose if I have a collection of charges in a body and if I ask you what is a net charge, as we did in this case, we just have to add the charges along with their sign. That is here plus 5 minus 5. I should not tell 5 and 5, so it is 10. It is wrong. So when I say charges are additive, I just have to add it along with the sign. That is plus 5 minus 5. So the charge is 0, right? So first property is charges are additive. Number 2, charges are quantized. What is the meaning of that? When I say a body is charged, it is always how many electrons are more or how many electrons are deficient, right? So always we tell total charge is nothing but Q is equal to N into E, where N is an integer number and E is the charge of an electron, which is nothing but 1.6 into 10 power minus 19 coulomb. So always remember, if the number of electrons is given, charge can be calculated using the formula Q is equal to NE. Then the third important property is charges are quantized, right? Suppose if a body is having some charges, I cannot destroy that charge, but what I can do is I can only transfer the charge from that body to another body. So we can never create a charge or we cannot destroy the charge also, but what is possible, we can only transfer it from one body to another body. And the last property is when I keep two like charges nearby. Suppose there is a charge say Q here and there is also a charge say plus Q here. So they are like charges, so they don't like to be nearby. They will repel each other like this. This charge would like to go this way and this charge would like to go this way, right? Suppose if I have a charge say plus Q and minus Q, they will attract. That means they both try to come close to each other. So that is the meaning of like charges repel and unlike charges attract, right? Next, what did we learn? We learned about Coulombs Law. What is Coulombs Law? So basically we are talking about forces. How much force will a charge experience due to another charge? So that was explained by the scientist Coulomb. So when we have two charges, say, see here, Q1 and Q2, and they are separated by a distance, say, R, right? So how much force of attraction or repulsion will be there between the two charges? So Coulomb said that this force of attraction or repulsion between any two charges is directly proportional to the product of the charges. See here, Q1 into Q2, that is nothing but the product of the charges, and it is inversely proportional to the square of the distance between the charges. So this is the square of the distance term, and this is your product of magnitude of charges. So generally we can tell this also like this: F is proportional to Q1 Q2 by R square, right? And 1 by 4 pi epsilon naught, this is nothing but a constant of proportionality. And already I have given you these numbers in classrooms. These are the constant values. Suppose here I had two charges. Instead of that, suppose if I have, let me say, Q1, Q2, Q3, Q4, Q5, and so on, right? We have, let us say, Qn number of charges. So what is the charge on, what is the force on charge Q1 due to all these charges? So it is also given as F Q1 is equal to Q1 divided by 4 pi epsilon naught summation I is equal to 2 to N Qi by R1 I square. I hope this derivation is already done in class and all of you have already taken down in your notes too. So just go through it once again how this final formula came, right? Next is electric field. So this is a very, very important term which you have to understand in detail. See, I have a charge Q here. In the diagram you can see this capital Q, and we know that whenever a body is having charge, so here I'm having a body who is having a charge Q, so definitely it will exert a force, right? Right. But suppose, let us say I have some other charge Q here. Will this charge be able to exert its force on this charge? That is my question. So we have to understand something in that. How long or what is the range up to which my charge can exert its force? So always when I take a charge Q, there will be a finite space around the charge like this, right? So suppose if I bring this charge within that space, then it will experience a charge. Then it will experience a force, right? So this space that is surrounding the charge where another charge will experience its force of attraction or repulsion is known as electric field, right? So what is electric field? It is nothing but the space around the charge where any other charge will experience a force of attraction or repulsion, right? Suppose I have only one charge Q. So how much force will this charge Q experience due to another charge Q? See, who is going to exert the force? This capital Q. So we call this as source charge. So this capital Q is known as source. And this small q is known as discharge. Suppose if I have only one charge that is concentrated in a point. Okay, that we just have a point, within that all the charges are there. So that is known as a point charge, right? In such a case, electric field can be found using the formula E is equal to F by Q. We usually call this term E as electric field intensity. So how can we define this electric field intensity? It is nothing but the force experienced by a unit positive charge. That means when we bring this charge within the region of that source charge Q, it will experience force, and how much force it will experience when we bring within that space is nothing but electric field intensity. So E is equal to F by Q, right? Suppose I don't know which charge I am bringing in, but I know how much electric field, but I should know how much electric field that a charge can exert. So for that also we have a formula. Suppose only source charge you know, then you can calculate electric field using the second formula that I have given, that is E is equal to capital Q by 4 pi epsilon naught R square. See carefully, the first formula E is equal to F by Q. In that also we have Q, but that Q is test charge. Whereas in the second formula you have a charge capital Q, and that is nothing but source charge, right? Suppose now I don't have a point charge, but I have a charge, but it is distributed uniformly in lengthwise. Okay, you understand? Can you see this picture? It is lengthwise the charges are distributed. So in such case, how can we find the electric field? So for that also we have the formula A is equal to 1 by 4 pi epsilon naught integral lambda dl by r square. So what is this lambda? Already we have discussed this very deep in detail in our classroom. So lambda is nothing but number of charges present in a very small length, say dl. So it is also known as linear charge density. So what is linear charge density? It is the number of charges present in a small length. Similarly, suppose if the charges are distributed in a whole surface, then we use the formula E is equal to 1 by 4 pi epsilon naught integral sigma dA by r square. What is this sigma again? It is nothing but number of charges present in a particular area. Or you can see here sigma is equal to Q by dA. It is known as surface charge density. Next, suppose if the charges are distributed in a whole volume, then electric field is calculated using the formula E is equal to 1 by 4 pi epsilon naught integral rho dV by r square. So these again we have rho is equal to Q by dV. So these are the different formulas that we use for calculating electric field, which we will be using while we do our problem. Suppose if they tell the charges are distributed along the length of the conductor, you have to use formula lambda dl. Suppose if they have said along the surface, then you have to use the formula sigma dA. Suppose if they tell the charges the point charge, then you have to use the formula Q by 4 pi epsilon naught r square. So depending on the situation, we will be using the appropriate formulas. Next is electric field lines. So when I always tell electric field space, it is a space and all those, there should be some concrete evidence, or there should be some concrete method of showing you how the electric field is. So for that, the pictorial representation of electric field is only known as electric field lines. So these electric field lines have some properties. So I have listed down those properties also for you. So already we have discussed again this also in our classroom. So number one, they start from positive charge and they terminate at negative charge. So please remember, always electric field lines will start from positive and they will end at negative. Again, you don't have another loop starting from negative to positive. You understand what I tell? So I'll just explain it here. So suppose you have a charge say plus Q here and you have a charge say minus Q here. So always the electric field will go from plus Q to minus Q. This is correct, but again it will not go from minus Q to plus Q. This is wrong. It will only always be going from plus Q to minus Q, right? So these things you should be knowing. Next, they do not form closed loop. Of course, they cannot form closed loop. Why? Because always it is going only from plus Q to minus Q. It will not go again from minus Q to plus Q. So they do not form closed loop. Number three, suppose I am just given the diagram of electric field lines. I'm just worried about how to find the electric field from that. So don't worry, you just have to draw a tangent at the point where you are expecting to know the electric field. So suppose if I want to know the electric field at this point, say, so I will draw a tangent at this point, which will give me the direction of electric field at that point. Then the next property is electric field lines never cross each other. It is not correct to draw two lines crossed. Okay, they can never cross each other. Then they are always perpendicular to surfaces. So these are very important points which you have to remember. So from the next upcoming video, we will be going into discussion. We will be discussing deep in about dipole and electric field due to dipole. Thank you.